This brief tutorial is presented to you from the Public Health Centers for Excellence and will focus and provide a brief introduction to understanding variation and process. In the next few minutes, we will review what variation and process is and what it looks like. Review the types of variation and why it's important to understand these types in order to guide our actions. We'll review briefly some related concepts, apply this knowledge with a quick quiz, and of course provide some additional reference material for further follow-up. So what is variation and process? Simply, variation is the difference between two or more similar things. Now we know that all of our work processes are made up of a series of steps that we take to deliver our services and products to our customers. All of our processes have some degree of variation built into them, either intentionally or accidentally through inattention. Since our ultimate performance in terms of service or product quality is determined by processes, variation in process will result in variation in the quality of our product or service. In this simple graphic, we have a series of steps that our fictional employee Bob does to produce a specific product to the public. But perhaps there is significant variation in, say, step 2 of this process between different employees. Joe is responsible for providing the same service or product to the public, but he does step 2 differently than Bob. And the way Bob does it produces a different level of quality than Joe. And perhaps Mary does step 2 the same as Bob, but does step 3 differently than either Bob or Joe. Now again, what Mary delivers in terms of quality may be different significantly from what Joe and Bob provide. In public health, we don't want to deliver some services exceptionally well while we provide other services just so-so. The goal of our quality efforts is to consistently produce high quality in all that we do. To continuously improve our performance, improve the quality of our services, we must understand the concept of variation and the variation that we see within our processes. We do this by studying our processes. Another way to look at variation in process is to use charts. This is a generic example of a run chart, which is a key and simple tool in quality management that helps us to study processes. You have some quality characteristic reflected on the y-axis. In this example, it's incidences per month. Incidences per month could represent client no-shows or missed appointments, or findings in vaccine audits, etc. Time is reflected on the x-axis, in this example spanning 13 months from January to January. In visualizing this data, we see a great deal of variation. Some months the data goes up. Some months it goes down. Occasionally, you have a couple data points going on in the same direction as you do starting in September before it goes back down. You can clearly see in this chart the variation in the process. The question is, why is this happening? This module is aimed at helping us answer the question why, and also the what, if anything, we should do about it, depending on whether the variation is intended or not. Now, it's commonly said that the only acceptable variation in our processes is that which is desired by our customers. Intended variation might be aimed at meeting the needs of a set of customers. For example, flexing our hours of operation to meet the needs of working adults, or tailoring our messaging to different audiences during a public health emergency. This sort of intentional variation helps us meet our goals more effectively. In contrast, unintended variation adds unneeded complexity to our work processes. So our goal with quality improvement is to eliminate as much variation as we can, thus complexity from our processes as we can. Now, all of our processes have some degree of variation built into them, either intentionally or accidentally through inattention. So what causes variation in process? Variation in our processes can be driven by technology that we might be using, different people providing the same service, shifts that employees might be working in, such as day or nighttime shifts, differences in the methods we use, and the environment can contribute to variation, such as what might occur between different clinics that we might have off-site from our primary location. And there are many other potential sources of variation. There are two types of variation that we must distinguish. These are common cause and special cause. Common cause is built into our processes, reflecting a process that is stable with variation that is predictable. To improve common cause variation, you must change the process. In contrast, special cause variation is not an everyday part of our processes. Special cause can be observed in different ways. It can be seen as a shift in the data points or by a single data point outside of control limits. We speak to patterns of variation in another tutorial on run charts. To improve special cause variation, you must address the cause alone. You do that by investigating it. You do not change the process. Why understand variation? Because our ultimate performance in terms of service and product quality is determined by our processes that we've designed and the underlying variation that we've designed in them. To continuously improve our performance and improve the quality of services, we must understand these concepts and the types of variation that we see. It's important to know which kind of variation is occurring because we take different actions in response to the different types. This helps us to focus on making data-driven changes to the processes. We do not focus on an isolated occurrence or event. If we act inappropriately to expected or predictable variation, our actions can actually destabilize a process that is in control. Addressing a single occurrence of common cause variation is called tampering with your process. Tampering can be hazardous to organizational performance. Here's a simple table to help guide actions based on the types of variation that are identified. If the cause of variation is common cause, then the actions to take is to change the process, shown in the middle column here. Common cause variation represents about 94% of all the variation we see in processes. The responsibility for changing the process would fall to a QI team or project. If the cause of variation is special cause, then the action to take is to fix or mitigate the issue detected by the data, seen here in the right-hand column. This is not a QI project. Special cause variation represents about 6% of all the variation we see in our processes. The responsibility for investigating the special cause would fall to either a manager or staff, not a QI team. This is a simple decision tree that helps to guide our action based on the type of variation that we see. Acting on variation again appropriately, meaning according to the type of variation we see, will help ensure ongoing process stability. And of course, taking action on a variation assumes that your process is capable of meeting customer needs. We'll talk about this further. Let's walk through it. The first question to ask is whether the variation you're seeing is expected or unexpected. If the variation you see is unexpected and special, meaning not an everyday part of your process, then the action to take is to search for and eliminate special causes associated with those few data points. You don't change the process. In contrast, if the variation that you see is expected or common, then you need to ask whether or not the overall performance of that process is acceptable, meaning is it capable of meeting your customers' and stakeholders' needs. If the answer is yes, the process is capable, then the action to take is to do nothing. You don't respond to expected random variation as long as the process is meeting your customer needs. However, if the overall performance of the process is not acceptable, meaning not meeting customer needs all the time or consistently, then the action to take would be to search for and eliminate the common causes associated with all the data points. This means changing the process, doing quality improvement, making it a quality improvement project. There are some additional considerations that you might want to read further about, and these are the concepts of process capability and process stability. We cover these in more depth in another tutorial, but briefly, process capability is used to determine whether a process, given its natural variation, which again is a function of how we've designed it, is capable of meeting known customer needs or requirements. These needs are also called customer specifications. The other aspect of work process is the notion of stability. process stability is the long-term performance level of the process after it has been brought under statistical control. In other words, it's the range over which the natural variation of the process occurs as determined by all those systems of common causes, people, environment, technology that we reviewed in previous slide. This is about how predictable our results are. In summary, understanding variation is crucial to selecting appropriate work processes for our QI projects. And responding correctly to the type of variation and not tampering makes our management and QI efforts more effective. Let's test our knowledge with a quick quiz. In this instance, there are two methods being employed to produce the same product or deliver the same service. Process A and Process B. Now these represent the same service, but they're being done in a little bit different ways. On procedure A, you see step 1, then a decision step in step 2, step 3, and 4. And in B, you see step 1, step 2, step 3, then a decision step in step 4, and then on to step 5. They both start with the input. They both have a series of steps, and they both have a decision step. Think about these two procedures and think about which of them might take longer to complete. If you answered B, you'd be correct. Procedure B would take longer to complete for several reasons. First, procedure B has more steps, so it's likely to take a little bit longer. But second, procedure B also has a longer rework loop. What does that mean? It means that if an input has to go through the decision step and maybe it's incomplete, it has to go all the way back to step 1, then revisit step 2 and 3 before it hits the decision state again. In procedure A, the decision step is located closer to the beginning, meaning it has a smaller rework loop. And an input that had to be repeated through this process would only have to revisit that first step. So what it means is, between these two reasons, where the decision loop is located and the fact that B has more steps, if these two procedures were delivering the same service, B would be taking longer to complete. Now, if time is an issue or a primary customer satisfaction measure, you'd obviously want to go with the procedure that took less time to complete, so long as it's delivering good quality, of course. Quality management is about finding and maintaining that one best way. And of course, there's always multiple ways of getting something done, but there's usually one best way of doing it, and we want to standardize to that approach. Limiting a variation is a key principle of quality management. Standardizing is quality management, and this helps us to achieve greater efficiency and effectiveness in our work processes. There are some other topics in this series that can be found at www.phcfe.org. I encourage you to look at the modules on process capability and stability and the module on run charts. There are also some other excellent resources that you can refer to further your understanding of variation. This presentation is part of a performance management and public health training series presented by Washington's Public Health Centers for Excellence and funded by a grant from the Centers for Disease Control and Prevention. The centers are located in the Spokane Regional Health District and the Tacoma-Pierce County Health Department. Our goals are to help local health jurisdictions and tribal agencies improve their results, prepare to meet public health standards, and achieve accreditation. In addition to this training series, we offer technical assistance and resources in performance management to improve public health outcomes. If you would like to talk with us about how we might assist you, please look at our contact information on the preceding slide.